Alright, today we're going to learn about trigonometry. So this is probably your first introduction to trigonometry. So we're doing a little reading, and then we're going to define some keywords as we work with our new concept in this unit. So, directions. Read through the following information about trigonometry and answer the questions that follow. Trigonometry. What is trigonometry? The very mention of its name makes some students very upset. Actually, trigonometry, or trig for short, comes from the Greek words trigon and mitri. Trigon means triangle, and mitri means the measure of something. So we are going to measure triangles in a new way. What if you have a right triangle and you know one angle besides the right angle and one side length? Could you find the other sides and the other angles? With trigonometry, you will be able to. Why learn about trigonometry? In fact, trigonometry is a very powerful tool. Every map and every building and all kinds of videos, navigation, and science concepts use trigonometry. Have you ever used a cell phone, went on Google Maps, or played a video game? Without trigonometry, none of these things would be possible. So how does trig work? A right-angled triangle is a triangle where one of the angles is 90 degrees. So we know that already. We've learned that in this class. The other two angles are complementary, meaning that their measures add to equal 90. So in a 90-degree angle, or triangle, we know that there's a right angle there. What it's saying is that the other two angles, this one and this one, are complementary because they have to add up to equal 90. Because remember, in a triangle, all of the angles add up to equal 180. So if this one's already 90, then these two also have to equal 90 because 90 plus 90 is 180. One of the most important things to consider is the naming of the sides in a triangle. So for trig, you have to be really careful with how you name sides. For trigonometry, you have to know these three important terms: hypotenuse, adjacent, and opposite. We've dealt with hypotenuse, and we've seen adjacent before in different ways, and we've kind of talked about things that are opposite as well. But let's keep reading to see what else we need to know. The longest side of the triangle is the hypotenuse. We already know that. We worked on that with the Pythagorean theorem, and it helped us solve for missing sides. This side is always across from the right angle. The other two sides of the triangle are labeled relative, so based on the position of one of the other angles in the triangle. So generally we name these angles theta. So this is a special symbol right here. This is a Greek letter. It's called theta. So when you see this symbol, it means an angle. So let's look at some examples. Here's our triangle. It's a right triangle because we see the right angle. The side opposite the right angle is the hypotenuse because this is the longest side in the right triangle. Notice theta is marked right here, so this is taking the place of angle A. It's a little symbol, looks like a little O with a line in it. This is your angle measurement, represents the angle. So now we have these two side lengths, adjacent and opposite. In the other example, the hypotenuse again is the side opposite the right angle. This theta symbol is moved in this triangle. We switched around where A is. We moved it around. We did a little rotation. The side opposite's over here, and this is the adjacent side. So let's see, what do we notice about the sides of each triangle? So one thing I notice is the hypotenuse is always the longest side. And it's opposite the right angle. Two other things I notice are that the adjacent and opposite can switch depending on their locations, or depending on where theta is. So theta impacts adjacent and opposite. Whatever those sides are that are indicated as adjacent and opposite depend on the theta symbol. So what side is always across from the right angle? So we kind of answered that question already. The side opposite the right angle is always the hypotenuse. So the hypotenuse is always across from the right angle. In example 1, so we're going to focus in on this example, what side is across from angle theta? So when I look at theta, what's the side that's across from angle theta? So across means I'm looking over it, I'm going through it, or opposite it. It's going to be the opposite side. So across from theta is the opposite side. And if you look at example 2, what's across from theta in example 2? So here's the theta. Again, the opposite side is across from this indicated angle theta. So again, theta is across from the opposite side. In each example, how would you describe the location of the adjacent side to angle theta? So let's look at the adjacent side and theta. So here's theta, here's adjacent, here's theta, here's adjacent. One way that I look at this relationship is that theta is always touching the adjacent side. The angle, the two sides that make theta, one of them is the adjacent side. So the theta is next to, that's what adjacent means, the adjacent side. So theta is next to adjacent. So we got some key words here that we have to be comfortable practicing and using. Let's try some definitions, and we can use those to help with our problems. Alright, so let's define each term, and then we can label them with the images that we have. So the hypotenuse we've kind of defined already. We know that. It's the longest side in a right triangle opposite the right angle. So I'm going to use the letter H for hypotenuse, and I'm going to label it. This is the hypotenuse, this is the hypotenuse, and this is the hypotenuse. It's the side across from the right angle. Remember, if you draw an arrow sticking out from the right angle, it'll point to the hypotenuse. We know that from the Pythagorean theorem. Then we looked at the word opposite. Opposite was the side across from the indicated angle, so the one that we're focusing on, theta. We were calling that angle theta. So the way I look at theta, here's theta right here. Pretend there's an imaginary flashlight here. It's my little picture of a flashlight. If you turn this on and you flash the light, what side is the light going to hit? And so in this case, here's theta, I'm flashing my light. The side that it's going to hit is over here. We're going to use O for opposite. So the opposite side of the theta is this side right here. We already know that this is the hypotenuse. This is the longest side. So there's only two choices left to determine which one is opposite. Opposite is always across from the theta. So again, if it helps, draw a little flashlight. Turn it on. There's your theta. It hits the side that's opposite, so this is your opposite side. Try again. It's a little flashlight. That one wasn't as good as my other ones. Turn it on, and this is the side opposite. So opposite is always across from theta. Adjacent then is the side next to the indicated angle. Theta. So in these triangles, we already know this is the hypotenuse, this is the opposite side. The adjacent side is over here. It's next to angle theta. Opposite, hypotenuse, adjacent. opposite, hypotenuse, and this is the adjacent side. It's next to. So you have to be able to identify these three sides. It's really important because when we start looking at the trig functions, which are called sine, cosine, and tangent, it's going to impact your answers. So let me help you out with the first set of problems that I want you to work on, and then you can work on your homework for tonight. So the first set of problems that you're going to deal with is I'm going to give you just some triangles, and you're just going to practice labeling. So what you're labeling is you're going to label the hypotenuse, and you can use H, A for adjacent, and O for opposite. So in each triangle, they give you the theta, and then you have to identify the pieces. So for me, the way to start these problems, the easiest one to get right is the hypotenuse. The hypotenuse is the longest side, and it's opposite of the right angle. So I can put an H here for hypotenuse. Then I think O is the easier side to identify of the two because it's easier to see what's opposite of the theta symbol. So in this case, this O is over here because it's across from theta. And again, remember, draw your flashlight if it helps you, and that helps you see which side is opposite. And then you have no other choice but to put A for what's adjacent. So same idea, this side is the hypotenuse, opposite, and adjacent because it's next to. So try those problems. When you're finished, you can get started on a homework that we're going to work on for the entire week, and then we're going to do it in steps. So when you finish this, let me know, and then you can work on that homework.